Welcome to today's lecture. So, in our last lecture, we had started with the numericals on hydrostatic forces. Okay, so we had seen the problems on total pressure and how to find out the depth of center of pressure. Okay, in our last lecture, we had seen the total pressure force is given by P equals to rho g h bar, rho g a h bar, and the depth of center of pressure is given by Ig sin square theta upon a h bar plus h bar. Okay, it is denoted by h star. After that, in our last lecture, we had also seen the problems. Okay, so we had seen two problems. In first problem, we had seen a rectangular plate which is inclined at an angle theta. In this problem, directly the value of angle was given. Okay. Also, we had taken second type of problem in which the value of angle was not given, but the positions of depth of center of both the ends. Okay, that is 1.5 meter and 4 meter from liquid surface. This was given. Okay, so today we are going to see the next type of problem, that is the problem on 1 minute. That means the problem on dam gates. Okay, so everyone write down a circular opening 3-meter diameter is closed by a disc of 3-meter diameter which can rotate about the horizontal diameter. Calculate the force on the disc and the torque required to maintain the disc in equilibrium in vertical position when the head on the water above the horizontal diameter is 4 meter. Okay, so quickly we will see the schematic, or we will see what is given in this problem. 1 minute. Okay, so you can see this is a tank which is filled with water, and on one side of the tank a 3-meter circular hole is provided. Okay, and this hole is provided with one 3-meter diameter disc. Okay, that means this hole, or you can say there is one gate. Okay, one gate, a circular gate of 3-meter diameter, it is provided. Okay, then from this diameter, or whatever the center line of this tank, the water level is 4 meter above. The water level is 4 meter above. Okay, so from the center, or from the center of this circular disc, the level of liquid water is 4 meter above. Okay, after that, one end of this disc, it is pivoted. Okay, suppose this is end A, so on this end A the disc is pivoted, while on the gate B there will be one gate, or some opening arrangement is given. You can rotate this. Okay, now what will happen if this gate is open, or if here the wall, there is some wall. So if this wall is open, okay, so what will happen, under the action of this water, a total pressure force P, it will going to act on this gate, and it will going to open the gate. Okay, so it will going to open the gate and all the water will spill out. So in order to keep this gate in closed position, okay, you are supposed to apply the external force. Okay, some external force F1 or F2. Okay, you are supposed to maintain the external force F1 so that the gate is open. Okay, that means if F1 it is less than P, so the gate will open. Okay, sorry, if this F1 it is less than P, or P is greater than F1, so the gate will open, and if the value of this F1 force applied it is more than or equal to P, so the gate will remain closed. Okay, so what is asked, calculate the force on the disc. Okay, so first of all, what is the value of force P which is applied by the fluid water? After that, what is the torque required to maintain the disc in equilibrium position? Equilibrium position means in closed position, so that the gate is in vertical position. Okay, so this is the given content. Okay, so you can see this is a schematic figure. This is a circular gate of 3-meter diameter. Its location of center of gravity, which is nothing but center of the circle from liquid surface, is 4-meter. Okay, this 4-meter will become indirectly h bar. So h bar is directly given to you as 4-meter. Okay, now under the action of this force, under the action of this water, okay, on this particular circular gate surface, a force of F will be acting at center of pressure P. Okay, so first of all we are supposed to find out the value of this F. After that, on the other end of the gate, what is the torque? Okay, this torque is nothing but, if we calculate the value of force F1, so that F1 multiply by whatever the radius of this disc, okay, or total distance. Okay, so that is the torque required to be maintained at other end. Okay, so we are supposed to find out the torque which is required to maintain the gate in vertical position. Okay, this is the given problem. Okay, very good, Sushil. Okay, so in this problem, the diameter D is 3-meter. So area will be pi by 4, 3 square. So you can calculate in calculator. You can cross check. It is 7.0685 meter square. Okay, 1 minute. Gaikwad sir. Okay, so it is 7.0685 meter square, and h bar equals to 4-meter. Okay, so force on the disc. Okay, so first of all, we will calculate the force on the disc. So we know the force on the disc is nothing but total pressure force. So this total pressure force is given by F equals to rho G A H bar. Okay, so here rho is 1000, G is 9.81, A is cross section area, that is 7.0685 into h bar. H bar is directly given to you as 4-meter. Okay, so calculate this 1000 into 9.81 into 7.0685 into 4. So the answer comes out to be 2,77,368 Newton. Or if you can divide, if you are dividing with 1000, so it will be 277.368 kilonewton. Okay. After that, we will calculate the depth of center of pressure. Okay, that means the location where this force F is acting. Okay, so the location of depth of center of pressure, or the depth of center of pressure H star. Okay, it is given by Ig sin square theta upon AH bar plus H bar. Now in this case, we know the gate is vertical. Okay, so if this gate is vertical, if you extend this gate, okay, it will going to intersect our liquid surface, making an angle of theta equals to 90 degree. Okay, and we know the value of sin 90. Okay, it is 1. Okay, so sin square theta ka value 1 aane wala hai. So the formula will be modified. It is simply Ig upon AH bar plus H bar. Okay, here Ig is nothing but center of gravity of this cross section, which is circular, about center of gravity G. Okay, so we know the formula. It is pi by 4 d to the power pi by 64 d to the power 4. Okay, so put all the values. So Ig is pi by 64 d to the power 4 divided by area. Area is pi by 4 d square into 4 plus 4, the value of h bar. Here pi will cancel, d square will cancel with d to the power 4, and you can also cancel this 4 with 64, so you will have 16. Okay. So on solving this equation, the value of h star comes out to be 4.14 meter. Okay, so basically the value of F, okay, whatever the total pressure force F, it is acting at a distance of 4.14 meter from free liquid surface. Okay, that means what is the torque applied by this force? Okay, so this is your liquid surface, this is your gate, okay, this is point P. Okay, so on left side of the P, one force is acting which is having the value F, and it is acting at a distance of 4.14 meter. Okay, so torque acting, and because of this, if you consider the moment about this point O, okay, suppose this is point O, so the moment acting on left side of the plate, it will be F into 4.14. Okay, and this moment it will be acting in clockwise direction. Okay, sorry, anti-clockwise direction. Okay, so it is 4 into 4.14. It is a torque which is acting, and because of this torque, the gate will going to open. Okay, but we are supposed to apply some external force F1 at other end. Okay, we are supposed to apply some force F1 on other end so that this gate will remain in vertical position. Okay, so basically what will be the distance of this point? We suppose this is point B, okay, lowermost point. So we know this distance is 4 meters. Okay, and if the diameter is 3 meters, so this distance is 1.5 meter. Okay, so this distance will be 1.5 meter. So this total distance of this other end B from point O, which is on the liquid surface, so that distance is 4 plus 1.5, so 5.5. Okay, so torque required, okay, the torque required T, okay, so it is simply this F1 into 5.5. Okay, so first of all we will solve is, so moment of this force about the diameter XX, that should be F. Oh, okay, sorry. Here the hinge point is this point. Okay, so you are supposed to take the moment about this point. आपको point O से नहीं लेना है moment आपको ये point से लेना है. Suppose ये ऊपर upper end is A, lower end is B, so you will take the moment about point A. Okay, why A? Because A पे pivot है. Okay, तो पाइवट होने के कारण आपका जो गेट है वो ऐसा ओपन होगा. Okay, this is B A, and after opening it is B dash. Okay, so it will going to open like this. So moment of the force acting will be F into this distance AG. So this AG is nothing but this total distance is 4.14 minus 4. Okay, so H star minus H bar. Okay, this will be, put the value, so F is 2,77,368 into 4.14 minus 4. Okay, so on solving this, it comes out to be 38,831 Newton meter. Okay, so this is the moment of the force which is acting on left side. So after this, we will see our next problem. So our next problem is a rectangular sluice gate AB, 2 meter wide and 3 meter long, is hinged at A as shown in the figure. Okay, so इस problem में आपको figure already दिया हुआ है. Okay, it is kept close by a weight fixed to the gate. The total weight of the gate and weight fixed 3,43,350 Newton, 343,350 Newton. Find the height of the water H, which will just cause the gate to open. The center of gravity of the weight and the gate is at point G. So what is given in this problem? See, in this problem, there is a dam. Okay, you can see, consider this is a dam, and on the lower side of the dam, one gate is given. Okay, so whenever there is no requirement of water on the turbine, or there is no requirement of water for the irrigation purpose, so in that case, this gate will be closed. Okay, so in order to keep this gate in closed position, there is some additional weight which is applied on the gate. Okay, so total weight of the total force or total weight applied is nothing but sum of weight of the gate as well as the external weight applied at point G. Okay, so that total amount of weight applied to keep the gate in closed position, that is 3,43,350 Newton. Okay, so this W, it is applied at point G. Okay, after that, whatever the diameter of the gate, it is given rectangular sluice gate. यहाँ पे meter है. Okay, there is some printing mistake here. The width is 3 meter. Okay, and 2 meter wide. That means perpendicular to the plane of laptop, the width is 2 meter and its depth is 3 meter or it is 3 meter wide. Okay. Now one end is always hinged. Okay, आपका जो point A है, that point is hinged, while this point B is free to open, but this point B is kept closed by applying the external weight W. Okay, so basically we are supposed to find out what is the height edge of water which we can fill in the dam. Okay, हमें डैम में कितना पानी मैक्सिमम लेवल हम भर सकते हैं such that the gate will just open or it will just about to open. Okay, that means आपने H लेवल तक लिक्विड लेवल तक वाटर को फिल किया, so basically गेट जो है it will about to open, और उससे आपने 1 mm या 1 सेंटीमीटर भी वाटर लेवल इंक्रीज किया, so basically gate will automatically open and all the water will come out. Okay, so we are supposed to find out this H, what is the maximum height of water which will cause the gate to open. Okay, so we are supposed to find this. So is the problem understood? Okay, so we'll proceed with the problem. So in the given problem, the breadth of the plate is given to us as 2 meter. Okay, and length of the gate, that is 3 meter. So basically area of the gate, which is rectangular, so we know the rectangular area is breadth into length. Okay, so 2 into 3, that is 6 meter square. Okay, after that W is given to us as 350 Newton. Okay, and theta is already given in the diagram. The theta is 45 degree. Okay, after that they had also mentioned the horizontal distance of this A from G. Okay, so this horizontal distance is 0.6 meter. Okay, that means whatever the location of G from A in horizontal direction, that is 0.6 meter, it is already mentioned in the problem. Okay, so we'll say let H is the required depth. Okay, when the water will just about to open the gate, and the depth of center of gravity, okay, that is denoted by H bar. So H bar is location of CG from free liquid surface. So from the figure now we know this H bar. So this H bar by geometry. Okay, now we will draw one vertical from A. It will intersect the ground surface at point D. Okay, so this is one triangle ABD. Okay, after that from G again we will draw one horizontal, so it will intersect this AD at point E. So we are having two triangles. One is AEG, second triangle is ABD. Okay, so in this bigger triangle ABD, this H bar, okay, this H bar is nothing but this H minus this distance ED. Okay, H minus ED equals to H bar. Okay, now this equals to H minus this ED. Now ED is nothing but this AD minus AE, AD minus AE. Okay, now again we will take these smaller triangles. We will take this smaller triangle A, E, G. So this angle is theta. Okay, which is 45 degree. Okay, so sine theta is opposite. Opposite is EG upon adjacent. Adjacent is AG. Okay, that equals to sine theta. Okay, AD. Sorry, AD. We are taking bigger triangle. Sorry. We will take this bigger triangle A, D, B. So this length is 3 meter and this angle is theta. Okay, so this sine theta. Okay, so sine theta. Okay, theta is this angle. Sorry, theta is this angle. Okay, theta यहाँ पे दिया है. So sine theta that equals to opposite. Opposite is AD upon adjacent is AB. So AD is nothing but AB sine theta. Okay, so we are replacing this AD as AB sine theta. Similarly, in this smaller triangle, okay, in this smaller triangle A, G, E. हमें eg का वैल्यू 0.6 गिवन है प्रॉब्लम में. ओके, सो हियर वी विल टेक tan थीटा. सो tan ऑफ थीटा दैट इक्वल्स टू ae upon adjacent is eg. So ae is nothing but eg tan theta. Okay, so is this understood? So we are just applying the geometry. So we will replace this AD as AB sin theta and AE as EG sin theta. Okay, after that put the value. So it is H minus AB is 3. So 3 sin 45 minus EG is 0.6. So 0.6 tan 45. Now we know the value of sin 45 is 1 by root 2 and EG tan 45 is 1. Okay, so you can solve this. So it is 2.121 minus 0.6, tan 45 is 1. So it comes out to be H minus 1.521 meter. Okay, so this is the value of H bar, the location of center of gravity from free liquid surface. So that is H minus 1.521 meter. Okay, after that we can calculate the total pressure force. Okay, the total pressure force is given by rho g a H bar. Okay, so it is rho is 1000 into g is 9.81 into a, area is 2 into 3, that is 6 into H bar we had just calculated, it is H minus 1.521. Okay, so you can solve this. Okay, so the answer comes out to be 58860 in bracket H minus 1.521. Okay, don't open the bracket because आगे हम इसको और further simplify करेंगे. Okay, after that next is we will find out the location of depth of center of pressure. Sorry, we will find out the depth of center of pressure. So we know the formula H star. H star is Ig sin square theta upon AH bar plus H bar. Okay, so here theta is already given 45 degree and Ig is nothing but for this rectangular plate it is BD cube upon 12. So 2 into 3 cube upon 12. Okay, so you can find out Ig equals to BD cube by 12, 2 into 3 cube upon 12. Okay, so it will come out to be 4.5 meter to the power 4. Okay, so put this value in above equation. So it is H star equals to Ig is 4.5 into sin square 45 divided by A. A is 6 in bracket H bar. H bar is H minus 1.521 plus H minus 1.521. Okay. So we can further simplify this. You can solve this equation 4.5 into sin square theta divided by 6. It comes out to be 0.375 upon H minus 1.521 plus H minus 1.521 meter. So this is the value of H star. Okay, the location of center of pressure P from free liquid surface, that is H star. Okay, so you can see in this diagram. So we had find out this distance H star. Okay, now again at this location H star. Okay, this is the value of location of P. Okay, force F. Now we will draw one horizontal from here. So again it will intersect this vertical line AD at point K. Okay, यहाँ से हमने vertical line draw की थी जो ground पे D पे intersect हो रही थी. Okay, so ये जो H point है, H point is nothing but location of total pressure F. F जो act हो रहा है. Okay, उसका location है, वहां से हमने horizontal line draw किया. So it intersect the line AD at point K. Okay, now we will do one thing. Now we will take the moment about hinge A. So what is happening on this gate now? On this gate there is some point G. Okay, यहाँ पे कोई point G है. G पे W act हो रहा है in downward direction. Okay, or there is one force F that is acting at point A, but F is always acting normal. So आपको F का vertical component लेना पड़ेगा. Okay, that will be acting in vertical direction. Okay, so आपको hinge से लेते टाइम आपको वर्टिकल डायरेक्शन में उसको रिजॉल्व करना पड़ेगा. ओके, सो बेसिकली ये जो W है हॉरिजॉन्टल में 0.6 मीटर पे एक्ट हो रहा है. ये आपका प्रॉब्लम में ऑलरेडी दिया है. ओके, सो मोमेंट ड्यू टू वेट इज नथिंग बट W into 0.6. ओके, So that should be equal to, or suppose that is acting in clockwise direction, so we will take that as positive or negative, suppose minus. Okay, फिर clockwise direction में कौन सा आएगा, मोमेंट ड्यू टू एफ. ओके, तो मोमेंट ड्यू टू एफ, बट एफ का आपको कंपोनेंट कौन सा लेना है, इन वर्टिकल डायरेक्शन. ओके, so that is f into ah, f into ah, sorry, f into ah, that equals to mode into eg. Sorry, 1 minute. eg. Okay, उन्होंने मोमेंट इन वर्टिकल डायरेक्शन ही लिया है. ओके, सो w into eg that equals to 1 minute f into ah. Okay, 1 minute. Now this is point A, this is point B. So basically this is point G. Okay, ये G point था, यहाँ पे W act हो रहा है. You had drawn one horizontal here, vertical here, so they intersect at point E. Okay, then this is point H. H point पे आपका F act हो रहा है. Okay, so you are drawing one horizontal from here, so that is intersecting at point K. Okay, so this is our schematic diagram. So we will take this W. So W, we are taking the moment about point A. So W into the distance is EG in horizontal direction. Okay, so that equals to whatever the horizontal distance. Okay, so that is F into AH. सॉरी, ये आपका फोर्स इस डायरेक्शन में एक्ट हो रहा है ना, सो आपको ये डिस्टेंस लेना है, F into AH. नाउ इन दिस ट्रायंगल AKH, this angle is again same angle theta. Okay, so opposite upon hypotenuse, that means sin theta. So sin theta equals to AK upon AH. So AH is nothing but AK upon sin theta. Okay, so by geometry AH equals to AK upon sin theta. So you can put here the value of AK. Okay, so that AK is nothing but F into AK upon sin theta, sin 45 degree, that is the value of AH. Okay, after that solve this on Cal C. F का value already आपको पता है, that is 58860 into H minus 1.521 into AK. AK is not known to us, divided by sin of 45 degree, that equals to 343350 into 0.6. Okay, so you can multiply this term and divide this term, so you will get the value of AK. Okay, so AK is 343350 into 0.6 into sin of 45. Okay, we are multiplied, divided by 58860 divided by H minus 1.521. So if you solve this on Cal C, so you will get 0.3535 into 7 upon H minus 1.521. Okay, I think this is a multiple 58860 and this 34350, they are the multiple. Okay, so on cancelling them, you will get this value as 7. Okay, and 0.6 into sin 45 is 0.3535. Okay, okay, I think यहाँ पे 7 नहीं आता है. Okay, 7 by mistake है. So AK is, okay, after that we know AK by geometry. Okay, this distance A to K. Okay, this distance A to K is nothing but H star. Okay, this H star minus distance AC. Okay, so this H star, 1 minute, this is point K. Okay, and this distance is H star. Okay, this distance is H star. So this H star, this total H star minus this distance AC. Okay, so you will get this distance AK. Okay, so this AK is nothing but H star minus AC. Okay, so this H star, okay, so this H star value is we had calculated here 0.375 upon H minus 1.521 plus H minus 1.521 minus AC. Okay, but that distance AC, so this AC is nothing but total length, okay, CD, that is H minus AD. Okay, again we will go to diagram. This entire distance is CD. Okay, this is point C, this is D. So this CD minus AD. Okay, this AD. So we'll get this value AC. Okay, so we will put that. So AC equals to CD minus AD. So AC CD is H. So H minus AD. Again, this AD is nothing but AB sine of 45 degree. AB is 3. So 3 sine of 45 degree. So H minus 2.121. Okay, so that is the value of AC. So you can put this value of AC in above equation. Okay, so we will have this 0.375 upon H minus 1.521 plus H minus 1.521 minus of H minus 2.121. So you can open that with negative sign. So it will become minus H plus H will cancel. Here we will have minus 1.521, and with this negative sign it will become plus 2.121. Okay, so finally that will be 0.6. Okay, or first term को as it is रखेंगे. Okay, so it is 0.375 divided by H minus 1.521 plus 0.6. This is the value of AK. Okay, now there are two equations. This is one equation, value of AK. This is second equation, value of AK. So we can equate these two equations. Okay, so equating these two equation, so we will have 0.3535 into 7 divided by H minus 1.521. That equals to 0.375 upon H minus 1.521 plus 0.6. You can multiply this entire equation by H minus 1.521. So यहाँ पे cancel होगा, यहाँ पे cancel होगा और यहाँ पे multiply होगा. Okay, so you can solve this equation. Okay, there is only one unknown, that is H. So on solving this, the value of H comes out to be 5.02 meter. So today we will stop here.